talk now about some model specifics. What the modeled listener is trying to calculate really is the probability of any particular interpretation. For instance, here, interpreting the pronoun as the subject, which is singular, given the context, right? Given the particular context involving the pronoun's form, whether it's null or overt, the particular connective that's used, so either pues or porque in this case, and the morphology that's present, the singular or plural agreement morphology, right? And that calculation is going to be proportional to, first, the prior probability of that interpretation, that is the singular subject in this case, irrespective of the particular context, multiplied by the likelihood of these particular context values given this kind of interpretation that is a singular subject. So we actually can assume, or we are assuming in this case, that these context values are independent, so we can actually calculate the likelihood this way. So the likelihood of the form given the interpretation, the connective value given the interpretation, the morphology given the interpretation, separating these out. And it's actually not crazy to do this, in case you're wondering. It turns out that in visual perception, human behavior is best captured by models that assume features are independent, just like we're assuming here. So not crazy, who knows if it's right, but not crazy, and that's what we're doing here. And then this is going to be our baseline model. So it has accurate representations of information, and it's going to accurately deploy those representations in the moment. Now, okay, great. What about a modeled listener who has inaccurate representations? So this could involve inaccurately representing the prior, or the likelihood information, or both. So in this case, what we're going to do is implement this as a softmax on the true probability, the prior or the likelihood, with what we're calling a contrast parameter, sigma. So the softmax function is this. What it ends up working out to is raising the probability to that parameter, sigma. Right? And so the reason I kind of feel like this is a contrast parameter, or at least that's a nice way to think about it, is you can see that it either turns down or turns up the contrast, as it were, depending on the value. So if sigma equals 1, then the probabilities remain accurate. So let's say we have 0.324 versus 0.676. Sigma equals 1, they stay as they are. But if sigma is less than 1, let's say sigma is 0.5, probability differences are smoothed away. So this becomes 0.409 versus 0.591. And conversely, if sigma is greater than 1, let's say sigma equals 2, the probability differences are sharpened. So this now, say, becomes 0.187 versus 0.813, right? So you're turning up or turning down the contrast depending on sigma's value. And so we're going to have one sigma for each information type, so one for the prior and then one for each of the values in the likelihood, the form, the connective, and the morphology. And then we're going to allow sigma to vary between 0 and 4, so less than 1 and greater than 1, and to see which sigma value combinations best predict child and adult pronoun interpretation behavior. So that's our modeled listener with inaccurate representations. Lovely. What about a modeled listener who has inaccurate deployment of information in the representation? So this could involve inaccurately deploying the prior or the likelihood information, or both. Okay, so we're going to implement this as ignoring that information in the calculation. So for any piece of information, the modeled listener either pays attention to it, and so uses it, or ignores it in the moment, right? So if you're going to say ignore it, not use it, that means you're not going to incorporate it into this inference calculation. So let's say we don't use the prior. Well, then we're going to be relying on a uniform that is an uninformative prior, say 50-50 if there are two choices. If we're not using any of the likelihood information, that means we're just not going to use that cue's information. So for example, if we ignore morphology in the moment, we're not going to use the morphology likelihood, and the calculation looks like this, as if you just don't even bother paying attention to morphology in the inference. Now, for any information, just like before, the model listener could either use or not use it in the moment. And so use parameter beta is going to determine whether a particular information type is used or not. Now, just like before, each of the 4 information types, the prior and each of the cues in the likelihood, has its own beta, right? And now here's where it gets interesting, right? Because we can use or not use any of 4 possible information types, this is 16 possible use combinations for any particular moment, going from using them all to using none of them. right? And we're going to implement this with a mixture model, right? Which is just, for each one, we either use it or don't use whatever information types are for that particular mixture combination element right there. And so this is what it looks like. Again, it looks kind of complex, but again, it's just each of the 16 possibilities added together. And so we allow our betas to range between 0 and 1, and we just see which beta value combinations best predict child and adult pronoun interpretation behavior. So that's an accurate deployment. Now what about a modeled listener who has both inaccurate representations of information and inaccurate deployment of those representations? Great question. Well, as you might surmise, what we end up doing is implementing this as a combination of the previous two modeled listeners. So we have sigma, our contrast parameter values for inaccurate representation. So on each of our information types, we have a little sigma. And we have beta use values, right, for inaccurate deployment involving our mixture model, using or not using in the moment. So it's just a combination of these two pieces we just saw. And just to make this a little bit more concrete, each term of the mixture model is going to have a little contrast sigma associated with it, right? So that's just how these two pieces get combined. So this mixture model, the inaccurate both model has 8 parameter values, a sigma contrast and a beta use parameter for each of our 4 information types for 8 parameter values total. And so we allow the same ranges as before, so sigma contrast between 0 and 4 and beta use between 0 and 1, and we see which sigma and beta value combinations best predict child and adult pronoun interpretation behavior.